In this video, we'll look at graphing a transformed cubic. So I wrote down an equation, y equals 3 brackets a half x minus 2 cubed plus 4. But important note to self, before you do any type of graphing, common factor out this k value. That is, I'm going to pull this half out of this x here. I'm going to pull it out of this negative 2 first. Be careful, this is a source of mistakes for a lot of people. If you pull out a half here, this doesn't become 1. Because if you were to rainbow or expand this back in, 1 times a half would be a half. So you have to think, what would this be that if we put it times a half, it would be 2? The answer, of course, is 4. So we're going to have here x minus 4. Again, check that. A half times x is a half x, and then a half times negative 4 would be negative 2. So same equation, but now we can see the values. Okay, we're going to graph a transformed cubic. We need to start with the table of the parent function y equals x cubed. So let's draw the table. How many values do you need? I don't know, a few. And we should pick on either side of the middle. You should know, again, I would watch a video on cubics if you haven't, on how to graph the parent function of a cubic. You should know the parent function of a cubic is centered around 0, 0. So let's look at negative 2, negative 1, 0, 1, and 2. And how do you get these values? You just cube them. You should be able to do that in your head. If you can't, you can pull out a calculator. But negative 2 cubed is just negative 8. Negative 1 cubed is negative 1. 1 cubed is 1. 2 cubed is 8. Got my parent function table. Now I'm going to write the mapping rule, which is going to take all the x comma y's, all the points. Careful with this notation. It's like a point, x comma y with brackets, goes to, and I'll start off my brackets so I don't forget. Put brackets and a comma. What's happening to the x's? Well, there's a half here, but if you remember, the half, when you're doing x stuff, you have to do the opposite. So this half means do the opposite of divide by 2. Well, we're going to times all the x's by 2. Just like with this take away 4, we do the opposite of take away 4, which is plus 4. So we're going to take all our x's and times them by 2 and add 4. That's the mapping rule that the transformation of this cubic tells us to do. What's the transformation for the y's? We don't flip it, we do exactly what it says. 3 times the y's plus 4. And we've got our mapping rule, our recipe for how to transform this function. We'll take that recipe and we'll transform the table. So you can call this the new table or rewrite the equation if you want. We take our x's and do times 2 plus 4. Again, you can use a calculator, no judgments. 2 times negative 2 is negative 4, plus 4 is 0. 2 times negative 1 is negative 2, plus 4 is 2. And you start to see a pattern here. 2 times 0 plus 4. 2 times 1 plus 4. 2 times 2 plus 4. Got our x values. Our y value is very similar. 3 times y plus 4. 3 times y, negative 24, plus 4 is negative 20. What's next? Take our negative 1. And remember, you're not taking these x's. You're taking the original y's and transforming them with this. So 3 times negative 1 is negative 3, plus 4 is positive 1. 3 times 0, plus 4. 3 times 1 plus 4, that's 7. And 3 times 8, that's 24, plus 4 is 28. So now when we go to graph this, which I'll do down here, we're going to graph it nicely. So first I'm going to make the y-axis, doesn't matter which one you do first, then the x-axis, and I got to put nice even ticks. I'll use the centimeter scale and label some ticks. So right there, right there, there. And you can use a different scale on the x-axis than the y-axis. Notice on my x-axis, I only need to go from 0 to 8. So I guess I'm going to want to go, I need this to be 8. So if only I had a couple more ticks, I think I'm going to extend it and I can make it nice and big. So as I already have 6 there, I can make it just a little bit bigger. There we go. And add a couple more ticks in. Perfect. So now this is, I got to label at least every second tick. 2, 4, 6, 8. And then for my y values, I need to get from negative 20 to 28. Holy. So I'm going to make the ticks again, every half centimeter. But my scale is going to be very different. Oh, and I noticed I didn't label the axis. Very important. Before I forget, this is the x-axis, this is the y-axis. And I need to get up to 28 up here. I need the scale to be the same top and bottom. So I'm going to go up by 5. So this is 5, 10, 15. With me, you always have to label at least every second tick. So this is negative 10, negative 20. Okay, now graph it. At 0, we're at negative 20. At 2, we're at positive 1. That's somewhere in here. Remember, that's 5. At 4, we're at 4. Just below the 5. At 6, we're at 7, so somewhere above the 5. And at 8, we're up at 28. Almost off our graph, but not quite. Okay, last thing, graph it. Make sure you draw a nice curvy shape as best you can. It comes through this, but don't go to that point yet because it's got a curve later. There we go. And then come through here to this point. And again, don't go straight to that point because you're going to curve towards it. And you don't have to be perfect, but you do have to try and make sure that you show it's curved. There we go. We have graphed a transformed cubic, this equation, by doing the original table, the mapping rule, the new transformed table using this mapping rule. We plotted our points and graphed.